So today we're talking about TSS problems. Many industrial sites have them. Um, the key thing to remember, TSS is everywhere. And we talked about it in December. Your metals problems are quite possibly linked to your TSS problems. But TSS, total suspended solids, is everywhere. For those of you that don't know me, I'm Ryan Janik. I'm one of the founders of Mapistry. I'm a professional engineer and spent the past 13 years or so in the stormwater space. Mapistry, for those of you that don't know, is we really bring an online cloud-based platform to industrial stormwater permits. We focus entirely on industrial stormwaters for industrial facilities. We often work with in-house EHS managers, specialist staff to manage stormwater permits. Three things that Mapistry does. We do a lot of education. Webinars like this is a lot of how we spend our time. In 2017, we're going to be launching an online training platform to automate some of this for your staff, maintenance staff, EHS staff, environmental staff. But we do a lot of education both in person and online. The main part of our software is an online platform to manage the actual stormwater permit, inspections, weather alerts, rain logs, mapping, SWIPs, all of that is done through our software platform. And it allows companies to manage everything from one site to 100 sites and put them all on the same platform, make sure they're meeting all the monthly, quarterly, annual requirements, and really speeds up the paperwork process. And then the last piece we offer is really like a conventional consultant and engineering firm, everything from BMP design to trainings to developing SWIPs and site maps, kind of filling in the gaps wherever we can't do it with the training and software components. So TSS background, EPA benchmark, 100 milligrams per liter. Sorry, that should say TSS and stormwater at the top. California, a lot of states, most other states use this 100 milligram per liter benchmark. You can see California, Washington, Oregon, all have 100 milligrams per liter as their benchmark or action level for TSS. Some things to note, like in California, California has a 400 milligram per liter instantaneous benchmark, meaning if you exceed that twice in a given stormwater reporting year, you move into the next risk level. So there are some instant action levels that are used. For Washington, if you're discharging to a 303D impaired receiving water body, they use a TSS benchmark of 30 milligrams per liter, so a lot lower than kind of the general benchmark of 100 milligrams per liter. So TSS analysis, how is this done? And I'm going to go into a little bit more from the lab perspective, but what TSS is looking at any suspended particulates. And its size is generally greater than 1.5 microns. The greater than size depends on the filter size. There has been some labs that have been using 0.7 microns, but generally it's 1.5 microns. You won't see a lot of variation in results between 0.7 and 1.5. Total suspended solids is inorganic and organic components. There's also a measurement of sediment called SSC, or suspended sediment concentration. It's similar to TSS. It uses the entire volume of the sample. TSS is going to use usually about 100 milliliters of the sample and measure it that way. So it just depends on, it's a very similar measurement, sometimes used interchangeably. Sampling is done in a plastic bottle. There is no preservative in it. So unlike metals, where you might have some sort of preservative or acid, TSS has nothing in it. It's usually a clear kind of plastic poly bottle. What happens is the lab takes the sample and they put it through this filter here. And what you see is the filter and the glassware. The filter's right in the center photo is right at the center of the neck. And you pour the sample through and it slowly gets vacuumed through. And then you dry and weigh that filter. And that's the mass, the milligrams per liter that you're getting reported out. But the lab walks your sample through this process of filtering it, drying it, and weighing it on those little filter discs. They're kind of like a coffee filter. It collects any kind of sediments. The takeaway here to note is it's both organic and inorganic. So if you have small particulates of like leaf matter or something on it, it's going to get caught up in that filter and it's going to get calculated into that mass. So if you have like a chip of mulch or some other piece that goes into your stormwater sample, it's quite possible that it'll show up in your stormwater sample in the weight on that actual filter disk there. So TSS impact, what question I get oftentimes is, why is it bad? What's the problem here? TSS impact, you can infill streams receiving water bodies, so it can choke out vegetation that might be growing there. If you're filling in streams, it can potentially impact any kind of macroinvertebrates or critters that are living on the bottom of the stream. It can also clog up fish gills, the sediments, the suspended sediments in water. It can also impair light. And the problem with that is it reduces the amount of light available for aquatic vegetation in a stream, in a river, in a pond. Can also reduce oxygen. So we talked about TSS being inorganic and organic. If it's a larger fraction of organic material, as it decomposes, those organics break down and they use up oxygen in the water. And if you reduce your oxygen levels in water, you can harm aquatic life, fish, other macroinvertebrates, or even plants living in the water. So if it's a high organic content that's contributing to your TSS, you can also reduce the oxygen levels. The other thing with TSS is there's often, because it's all particulates, you have metals. So if you have elevated TSS, there's a good chance that you have elevated metals. And as we saw in the zinc one from December, is that can impair fish production. It can impair any kind of organisms, just kind of normal functions. So because of that link between TSS and metals, there's kind of secondary effects beyond just plain old TSS if it was silt sands, etc. So the question here is, in a picture like this, if this is your storm drain, what's the problem with leaves getting in there? There's a couple things. One, from a permits perspective, is TSS is organic and inorganic. Inorganic being like the sands, the silicas, the silts, those type of things. Organic could be those leaves that break down and add small particulates. If you look at that filter disk there, you see a bunch of little black specks showing up on it. Those are organic particles that got caught up in the TSS. Benchmarks don't care, permits don't care. It's why if you're an industrial facility and you're doing like inspections or maintenance on your industrial facility, it's really important to pull any kind of organics out of your storm drains because it could contribute to TSS exceedances to meet permit conditions. So a couple questions for the audience. Number one, what are some BMPs for stockpiles? And these are just some thought questions. One of the requirements of many permits, if not all permits, is to cover your stockpiles. And sometimes that's impractical. If you have a big aggregate or sand stockpile, how do you cover it? It can be too large. So for TSS issues, potentially you might want to put in a berm around it. You might want to put in some sort of filter, trench drains, catch basins, number of things. But the permit may say cover, but if it's too large, there's often exceptions around that you can build in, and some things to think about in terms of creating berms, creating filters to prevent TSS from reaching stormwater. So generally, what are some BMPs you guys use today for sediment? And this is, I've asked a number of classes this. Especially, it's a really good question to ask if you're doing training for like general stormwater awareness and you're talking to maintenance staff, etc. Just ask them what are 3 BMPs for sediment, and it really makes people stop and think about it as to what is it that we're doing out here. Most people come up with sweeping. Sometimes they'll come up with like cleaning out the storm drains. For your own kind of edification is stormline cleaning. If you've got historical sediments, vacuuming, jetting with vacuuming out sediments. It's good to do that on a regular basis to clean out storm drains, so you're not getting contributions from historical sediments into your stormwater discharges. The other thing is catch basin inserts or drain inserts or witches hats. You hear called a number of things, filter fabric, different types of inserts into drains. And then a housekeeping one is just vacuuming or sweeping right around the drains. And this is really important because that's the final point. If water's flowing as sheet flow across your pavement, across your parking lots into a storm drain, you really want to capture the sediment right next to the storm drains. So sometimes you have degraded pavement, concrete right around storm drains. That's all contributing small amounts of TSS to your stormwater. So as part of your housekeeping measures, a really great BMP is vacuuming around the drains. So when we're looking at sources, and we're going to step back now, we had talked a little bit about some specific BMPs, probably some you've seen before. But if we step back and look at sources, some questions you should be asking yourself or thinking about when you're looking at potential sources of TSS. One is, where are my erodible surfaces? Especially in industrial settings, you often have largely, high density, largely all paved, impervious surfaces, but you may have some small areas of erodible surfaces. And it may be something that you don't even think of if you have a landscaping area or an area that should be landscaped, by a non-industrial area, employee parking, that could be near a storm drain that you're sampling from or collects industrial stormwater. It's something you want to sample, or something that you will be sampling. You really want to pay attention to: do you need to improve landscaping? Do you need to put down jute matting, erosion control matting, or do you need to put in some like mulch or more permanent landscape to prevent sediment that's, even though it's not industrial, it could potentially show up in your industrial stormwater samples. Then obviously your industrial processes. Are there things that are contributing particulates? You also want to ask yourself, are we looking at really fine kind of dissolved, more on the turbidity level, or are you looking at actual particulates that are going to contribute to TSS? Is it the water is discolored from like tannins or leaves or vegetation breaking down, or is it particulates? Is it larger organics that are breaking down? And then you want to look at nearby sources. What is being tracked on to your site? What is being potentially aerially deposited? Talk about aerial deposition a little bit later, but the photo on the right is kind of a precursor to that. So sources. If you're looking at like on-site, maybe you have construction going on your site. Maybe this is an industrial activity for you, processing of materials, graded road base here. Any kind of stockpiles that could potentially be contributing to your TSS. This is a glaring source, hard surface, uncovered, no berm, no filter around it, big source of TSS on a site. The other thing could be track on. You may have trucks coming onto your site that are tracking on mud. Maybe they come from an unpaved site and are coming onto your site for processing. For example, if you operate a transfer station, you maybe have trucks picking up debris, trash, recyclables, etc., coming onto your site. They came off an unpaved site. They have mud caked onto their tires, and they're then bringing it onto your site. Another potential source is just nearby roadways. Maybe there's muddy roads from, construction. Maybe there's unimproved lots nearby, or maybe it's a more rural area. Nearby roads are bringing on sediments onto your site, potentially even from your employees. Maybe not even an industrial vehicle coming on site, but your employees tracking on stuff from nearby roads. The other thing is construction sites nearby. It could be track on to your site. It could be contributing to the roadways, then gets tracked on via employee vehicles or other traffic. It could even be, if you have construction next door, it running onto your site. It could be blowing sand or debris onto your site. So some things to think about if you have TSS issues, some potential sources. And another one, a big one, is, from your neighbor, who's contributing to your own TSS. Do you have a swale or a curb cut or some sort of drain that's coming onto your site that's contributing TSS to your own problem? Unfortunately, once it's on your site, it's kind of your problem to deal with. There's not really a way to get out of it without going through some hassles. So as much as you can do to prevent run-on, you're better off in the long run. So to think about that in terms of an investigation, if you have TSS issues, what are the potential sources? Your neighbor is quite potentially one of them, especially if you have some sort of hydrologic connection to your neighbor. The other thing is your industrial processes, or yourself. You may be doing aggregate processing. You may have some sort of TSS from that, but it could be your forklifts. If you're turning, braking, grinding, those small particulates are getting onto your surface. And we talk about it from a metals perspective. Forklift tires high in zinc, but that also contributes to a TSS reading. That has a mass. That little rubber particle has mass to it. If it's winding up on the surface, it needs to be treated just like a dirt, sediment, sand, because it can show up in the TSS samples and potentially cause you to exceed benchmarks or action levels, etc. Same thing is if you have a site that's degraded. If you have degraded concrete, spalling, cracking, chipping up, especially near storm drains. I was talking about earlier, vacuuming around storm drains. But if you have worn pavement, worn concrete, these can be contributing small particles. And I hear it often, the response is, oh, we do a great job housekeeping, we sweep. But if you sweep, it could be tearing up some of this. So it makes sense. Not only are you doing really good housekeeping from a sweeping perspective, but you have to be doing really good preventative maintenance on your physical infrastructure of your site, and making sure that you're not contributing sediment, even though you're on a paved surface, sediment from the breakdown of your physical infrastructure. And then another thing is aerial deposition. So if you live in an area where there's mining or processing of sediments, aggregates, sands, gravels, rock, it's quite possibly, or if you just live in a windy area, high desert, other areas where wind-blown sediment silts can show up on your site. They can show up on your roof and then come down a downspout like you're seeing here, the staining. It's accumulating on a roof, and then once it rains, it comes out that pipe as a concentrated form of TSS. So aerial deposition can contribute a number of ways to your TSS issues. If it's getting aerially deposited on a roof, there's a couple things you can do. You can do regular roof washing. You could put in some sort of downspout filter. You could put in a planter. A planter is a great way to handle this because it's aesthetically pleasing. It helps from an aesthetic standpoint, but it also can filter out sediments. A planter with just a mulch layer on top and a really well-draining underdrain can filter out quite a bit of sediments as it goes through that planter. The other thing to pay attention to is historical sediments. Even though it may have been a while since you ever, popped a catch basin, popped a manhole, looked in there. If you have TSS issues, this is something we find very frequently. Is there's just a buildup of sediment. If you're in if you have a lot of exposed sediment around your site or on your site, gravel, rock, driveways, parking lots, etc. Generally, over time, that stuff winds up in your storm drain. So even though you might have implemented really good BMPs, there may be something historically underneath those storm drain inserts that's contributing to your TSS issues. So if you're having TSS issues, it's worth jetting and vacuuming out your storm drains. Please make sure that you do not discharge that wash water directly out through your stormwater system. Any maintenance contractor that's worth their salt is going to plug the end, put a back truck in there, and suck out and dispose of it properly. Do not just jet out and wash out your storm drains yourself and send it into the river. That is really bad. It's considered a non-stormwater discharge. Unauthorized wastewater discharges, please don't do it. Make sure you get a good maintenance contractor to come in, jet out, back out the lines, and start with a clean system. So if you have TSS issues or if you have metals issues, even this is something to pay attention to.
So if I'm dealing with TSS issues, I'll know instantly in Mapistry's stormwater platform that I'm going over my benchmarks or action levels. And you can see that right here in the middle where it's showing that I'm trending over for the annual average. The other nice thing you can use Mapistry for if you're dealing with any kind of exceedances, but especially TSS, is go over to the maps and understand what your drainage area is and what some potential sources are. So if I'm dealing with TSS exceedances at this outfall here, one of the things I can do as part of my planning phase for BMPs is get an idea of how big of an area, and from that calculate some flow rates. And I can do that just by drawing a polygon here. So if I come up here to the right, grab the polygon, and I'm just going to do a quick delineation of a drainage area that might be draining into this for TSS issues. And if for this example, I'm going to cut across here. But in terms of the drainage area, I'm clicking on the boundaries, and then at the end, it's going to give me an option to add it to my drainage areas, and I can say outfall 1 drainage area. And I can see exactly what's draining into that, and if I click on it, I can see that it's an 18-acre drainage area. So if, for example, in California, using design storm standards, that's almost 1,700 gallons per minute. So I would want to look at rainfall records and really understand what the total volume is, whether some of that's going to infiltrate in, et cetera.
So overall, I've kind of see it time and time again on sites with high TSS. There's a number of kind of go-to BMPs that I like to use, to remove TSS, to reduce TSS, those type of things. On a site that's largely impervious, so it's got a lot of pavement, a lot of concrete. I mean, sediment removal, sweeping, 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 sweeping. As much as you can do with sweeping, it's just going to help in, I mean, sweeping is probably the number one BMP I recommend on TSS. If you've got an unpaved site, what can you do to put gravel down? Um, some people will use dust suppressants. There's kind of mixed opinions on that. You may get pushback from different regulators on potential groundwater impacts, runoff impacts, those type of things. So look into that if you're using dust suppression chemicals. Um, but what can you do in terms of a paved site or even just like packed gravel? You know, sweeping is probably the best BMP out there. Most industrial sites have pavement. A lot of them, if you've got like a mix of paved areas like concrete aprons in front of buildings or concrete swales, if you can do sweeping, even hand sweeping on the swales, you know, if nothing else, do sweeping right before your sample points or where it enters the stormwater system. So that concrete swale that runs into your storm drain should be swept daily, weekly. If you've got a whole site that's paved, you know, monthly, quarterly sweeping, depending on the amount of TSS you're getting on your site, is a really great way to go. It's not that cost intensive to bring in a third-party contractor to run a sweeper around and make sure it's a vacuum sweeper or regenerative air where they'll blow the air down to dislodge particulates from the paved surfaces. But sweeping, best BMP out there. I put it every time I get contacted. Our customers have TSS problems. Increase the frequency of sweeping. Do more sweeping yourself. That's number one BMP. Inlet protection. Looking at potential inlet protection. That could be filter socks. It could be inserts. Those type of things can really help from a sediment perspective. And then clean out your drains. I always ask, you know, if you have TSS issues and you're doing 1 and 2 and you're still having problems, what's in the drain? What is it that's there that's getting scoured out or contributing to your problems? Oftentimes, this is more a metals issue because it's lower levels, but TSS still can be impacted by historical sediment deposits. And then when you're doing your follow-up sampling, if you're still having problems, you know, obviously you're doing your TSS sampling, but look at particle size distribution. You know, see what you're dealing with in terms of particle sizes. If you still are not hitting it with those first 3 BMPs out there, and you're wondering why, you know, you've put in filtration. Why is there, you know, why do I still have high TSS? Inspecting and changing out inserts regularly. It may be particle size. It may be very small particles that aren't being captured in the filtration. Question about, you know, TSS linking to aluminum. You know, if a site doesn't have an aluminum source on site but has some exceedance in TSS and aluminum, very definitely you see some soil types being really high in aluminum. It depends where they are. I know there's definitely parts of California, different quarry operations or aggregate producers that have issues with aluminum purely because of what they're processing, you know, whether it be sand or gravel. So what I would do if you have aluminum issues, I'd look at a couple things. You know, is there aerial deposition? Is that an aluminum source? To measure that, I would look at any kind of roofs and collect a stormwater sample, or even just wash off some of it and collect it in a sample container and get that analyzed for aluminum. You could also look at it as total aluminum versus dissolved aluminum. If it's largely total aluminum, maybe some sort of particulates. You could also look at surrounding areas. Are there areas that don't have pavement or mulching or landscaping? You know, is there an erodible surface somewhere on the site that could potentially be contributing the aluminum? So yes, very definitely TSS aluminum linked. If you have high TSS levels and high aluminum levels, it's quite possible that the aluminum is showing up as a particulate aluminum, which is total aluminum, has both particulate and dissolved, are added together to form total aluminum, which is what permits require for sampling. So if you have high TSS, it's likely the fraction of total aluminum is largely in the particulate form. Typical TSS in industrial sites in California, you know, what is the typical TSS in California? I don't know if there's a typical. It depends on the industry. You know, if you're talking like material, you know, industrial materials processing, et cetera, your averages are going to be probably, you know, a ready mix facility is probably going to be 100 to 200 milligrams per liter. You know, if you're aggregate processing, unpaved sites, I mean, you could be up over 400. We've dealt with sites that are well into the 1,000+ range, you know, generally unpaved site. the problems there are they're not doing BMPs. They're not doing structural or non-structural BMPs. Um, so in California, they have a number of risk levels associated with their permit. So far, generally, any of the companies that come to us that have exceeded previously, we're generally able to get them under 100 milligrams per liter. I think almost all of our customers are going to be under 100 milligrams per liter across the board, the ones that we actively work with. But that's done through a combination of training, non-structural BMPs, and structural BMPs. It really takes a complete buy-in, honestly, from top level, C-level management all the way down to maintenance staff that you're going to fix this problem. But yeah, the question was, how much are we able to reduce it? We can bring it under 100 milligrams per liter. So quick reminder, if you guys want help with training software services, please let me know. We use the software as much as possible because it is really much more cost effective, time effective than consulting services. And it gives facilities real-time insight into their operations and what the status is and how things are going. It also helps spot problems before they start. We're pretty actively involved in monitoring our customers' facilities and working with them. That's one of the reasons why we've been so effective at reducing, say, TSS below 100 milligrams per liter. Is not just put a BMP in, walk away, but staying actively involved. And that's one of the big differences between probably us and any other consulting company. We're very different in that perspective, is that we're very actively involved. The software allows us to do it without being overly expensive. So if you have questions on Mapstry or just questions on TSS and BMPs, feel free to reach out.